something that consumes electricity rather than produces it like a battery. It has a similar effect kind of in reverse. So if I have two lights here and they are in series, this needs more voltage to be powered. Versus if I have them in parallel like this, it means they're going to use more current. The other important thing to note is, hopefully we're all familiar with, a current needs to be a closed connection all the way around. So if I have things that are in series and one of the connections breaks, so for example, if one of these lights burns out, it breaks the total connection, and all the other lights will also turn off. Versus if you have things in parallel like this, if one part of the circuit breaks, like if this light goes out, the other light can still close the circuit, and so the other light will be on, but then the current that was flowing through both of these equally will now just go through this one, so that might also damage it. Again, things to touch on later. These principles won't come up generally unless you need them to. Again, it's something to Google, and it's something per project that you might want to refresh on, but I just want to introduce them. So we also have a checklist for things that you're probably going to need for getting started with Arduino. This is a picture of a sample project. I don't even know exactly what the project does, but this is what a board looks like, right? It is just kind of a simple computer, and then you have a power supply coming from this 9-volt battery. These wires are here to connect everything. This is what a resistor looks like. This is what adds resistance to a circuit. You have lights, you have these knobs. I will go over the stuff in detail, but thought looking at a project might be helpful to get an idea for what it looks like. Right? So first thing is resistor. So a resistor causes resistance, which given a voltage will force the amount of current that can be drawn to be limited, which sounds complicated, but essentially there's a certain amount of current that you can pull from a battery, and it's kind of rated differently by battery. And if you know there's a device that takes less than that, you're going to want to throw in a resistor so that it only gives the device what it needs, because if you give it more, it can cause a lot of issues. So also generally, I've mentioned earlier to never just have a complete closed loop from front to the back of the battery with no resistance. So generally for a lot of like modules that we use, we'll just also throw a resistor in there. So just in case, you know, something in the module doesn't quite work properly, it doesn't completely have that circuit straight from one end to the other. The resistor will slow it down a little bit and stop anything horrible from happening. So pretty much everything has resistance, and you can measure that with certain tools. Again, I don't think you'll need that. You can just do a lot of this math and a lot of it kind of figured out intuitively. I didn't get any tools for that until I was well along. But just know that most things have resistance inherently if they're using the electricity in some way. Like these LED lights here, they have a certain amount of resistance, and just making these currents, you should making the circuits, you should understand that, right? Because if I have 6 different things that are all powered by the same battery and none of them are working properly, then maybe these things are just pulling more current than they have access to. So for getting started with Arduino, you're going to need a power supply, and you're going to need a cable that can interface with your computer. They're really easy to come by. Chances are you have one of these lying around already. I will also mention that there's a lot of tiny electrical connections that this cord makes with your Arduino and with your computer, and generally it works perfectly. But some of these cords don't have the 6 teeth or whatever that they need to communicate. They only have a power, the voltage and ground, right? So they only have 2 teeth to help complete a circuit. And so if you're charging something, those cables work perfectly. But when you actually need to communicate information, you're going to need a smart cable. So the easiest way to test that is just plug it in to your computer, plug it into your Arduino. Your Arduino will have different interfaces. If we go back and look at the one earlier, right? So this is a different kind of port. You'd use a different kind of cable to connect it to your computer. But you just try it, see if you can upload something, see if you can communicate with the Arduino at all. And if you can't, chances are it's probably just a power cable. You're going to need another one. The other one is the Arduino IDE. So this is where you write code. If you've written code before, you know that environments exist. You write code in an environment. This is the Arduino development environment. Again, something to Google. You'll probably have a problem or two installing it. I don't know exactly what that problem will be. There's obviously millions of different issues that can go wrong with it. Just keep Googling it, read the forum. There's a lot of things to help it go way smoother. So here, you know, an installer, you don't really have to get too custom with the options. You can just kind of get the IDE any way you can, right? And this cord will generally also power your device, right? Because it still does have those power lines, but once you've uploaded the code to the Arduino, then any time that you power it, it'll automatically just run that code, right? So there's already been code uploaded to this Arduino, and now that it's being powered, it's running it. And I don't know exactly what this program does, but it's working because you can see the lights are on, and I'm sure there's some logic here that the creator intended. So do not short anything. You need some resistance always. I've mentioned this earlier, but you can kind of see, you know, they have the resistors set up here. Generally, I would say try to put because you can put things in any order in a circuit. Generally, I would put the resistance right after the battery. So that way, most of the, you know, wire that's coming out of it, or most of the logic that you're playing around with, has the lower current because the resistance is already there. So if you accidentally connect two wires, or you know, accidentally put one of these in the wrong slots and it goes all haywire, that it's a lower current and it's not the higher current that could fry something, right? So this thing that all these wires are plugged into is called a breadboard. We'll go over how that works later, but it's just another thing to put on your checklist. I have a more in-depth checklist later, but I just want to at least show you a little bit what it looks like. So yeah.